Hey everyone, today we will be solving a question 23 on Cayley 2018. A container in the shape of a triangular prism stands on one of its triangular faces. Three spheres of radius 1 are placed inside the container, each touching the triangular bottom, and each sphere touches two of the other rectangular faces of the container, and each sphere touches the other two spheres. A fourth sphere of radius 1 is placed on top of the three spheres, touching each of the three spheres and the top of the prism. So this question wants us to find the volume of the prism. So take some time and pause this video, or if you already have the solution, just feel free to continue. Welcome back, everybody. Let's get started. Firstly, we should know that the formula for finding the volume of the prism is equal to the base times height. And in this question, we have a triangular prism, so the base is a triangle, and it also mentioned that the faces are rectangular, so the length of the rectangle is just equal to the height of our prism in this scenario. And we should also know that all of the spheres are identical, and they all have a radius of 1. Great, now let's start solving for the volume. Firstly, we can take a look at the base. So the question stated that each of the three spheres are touching the triangular bottom. So we can deduce that the three spheres on the bottom are all touching the base. So now let's just draw the spheres on the bottom together. We know that it's like this. And we also know that each of the spheres have a radius of 1. So we can just draw out the centers of each of the circles and connect them in a triangle. Since all of the radiuses are equal, we know that all of the sides of the triangle is equal. So this will be an equilateral triangle. And we can just find the height of this triangle because each angle in the equilateral triangle by definition is 60 degrees. Sine 60 degrees is equal to h over 2, and h is equal to square root of 3. So this is our base, and we know that this length over here is equal to the square root of 3. This one is equal to 1. Let's start solving for the area of the base. So according to the question, each of the three spheres are touching the triangular bottom. So we know that all of these spheres are touching the bottom. So we can just draw them out. Here are the spheres on the bottom. And each of them all have an equal radius of 1. So we can just connect them. So we can see that the yellow triangle has a side of 2 on each side. So it's an equilateral triangle. And by definition, the angle of an equilateral triangle is 60 degrees. Now we can use this information to start solving for the length of the base. So if we just extend this line here, we know that this line and this line are parallel, so this is 60 degrees. And this line is parallel, so this is 60 degrees as well. And then we can just connect this here. So we know that this bisects this angle. So over here we have 30 degrees. And now we can just extend this. This is equal to 1 because it's the radius. So we can find this side by tangent. By using this trig function, tangent 30 is equal to 1 divided by x. X is equal to square root of 3. So this over here is square root of 3. And since this is the radius 1, this is also equal to 1. And by symmetry, we know that this is 1, and this is the square root of 3. So we now have the length of the base, which is 2 plus 2 times square root of 3. And we also know that the base is an equilateral triangle because each side is also 60 degrees. And the formula for the area of an equilateral triangle can be found by 3/4 times each side squared. So we can just find the area of the base. So after doing calculations, this is 6 plus 4 root of 3. Well, let's start solving for the height. Although it might be tempting to just say that the two balls are just stacked and here is the radius and the height is 4. This is actually wrong. The reason why is because that each sphere is curved. So the three spheres on the bottom actually creates something like a nest or a hole for the fourth sphere to rest on. This is why we need to think about the height of the sphere by looking at the distance between the spheres rather than just stacking them up. So I have drawn a diagram of each of our spheres. We can just consider them each of their lengths to be forming a tetrahedron. This is because although it's rather hard to visualize, each of the spheres have a distance of 2 because their radius is all equal to 1. This is the case for the bottom one, and this is also the same when we think of the two bottom spheres and one of the sphere on the top. So we can just construct a tetrahedron to connect all of their centers. And when we find the height, we know that this is 1 and this is 1 because this is the container and this is the height of the container. So we know that the center of the top sphere is 1 unit away from the top, and the center of the bottom sphere is 1 unit above the top. So now we just need to solve for the height of this tetrahedron in order to solve for the height of the whole container. Let's start analyzing the tetrahedron. So we can actually extend a line from its tip to the centroid of the triangle. Note that when we are dealing with a regular tetrahedron, we can state that the tip is directly above the centroid, but this only applies for regular tetrahedrons. And now we would like to find this line. So now I've constructed a diagram of our base. This is basically the centroid, and the centroid system states that the centroid is 2/3 the distance from each vertex to the midpoint of the opposite side, and I'll attach some links to the centroid theorem in the description if you are interested. So we know that this line is the square root of 3, so this is also the square root of 3, and this one is square root of 3 divided by 3, or a third square root of 3. We also know that this is the right angle. If you want to learn more about 3D geometry, just feel free to tell me in the comments down below or message Math Club. So this we can just use the Pythagorean Theorem. So the square root of 3 squared is equal to a third square root of 3 squared plus the height squared. So then we can just plug it in our calculator. 3 is equal to plus h squared. So h is equal to the square root of 8 divided by 3. Great, now let's go back on the top. So we know that the height is just 2 plus square root of 8 plus 3. Now we can finally start to calculate the volume. So we have calculated our base to be 6 plus 4 square root of 3. the height is 2 plus this. And we can just use a calculator because it's CIMC. So this gives us approximately 46.96807, and its closest answer is E47. Congratulations, you have solved the question. Thank you so much for listening to my video, and I hope to see you again.